Today we're going to do some math review, some things that you should have learned back in like elementary, middle school. So rounding is one example of the things that we're going to be using in this class. If we take the look at the number 513.9, to round it to 3 digits, we would want to keep the 5, the 1, and the 3. The number following the 3 is a 9, which is higher than 5, so it's going to round the 3 up. So we would have 514. If we wanted to keep 2 digits, we would keep the 5 and the 1. Following the 1 is a 3, so that's going to leave the 1 as 1. It's not going to round up. However, 51 and 513.9 are not on the same magnitude. If I owed you $513, I wouldn't be able to round that to $51 and you'd be satisfied. So we have to use a placeholder. So we can use a 0, and we can say that rounded to 2 digits, it's 510, where the 0 is just holding the place. Now we could also put this into scientific notation, so we're only showing those 2 digits, and we could say 5.1 times 10 to the second. If we wanted to round this to 1 digit, we would want the 5. The 1 doesn't round the 5 up, so it's just going to stay 5. Again, though, we have that magnitude issue where 5 and 500 are not the same, so we're going to put zeros in the placeholders. We could then take that number and change it to scientific notation to show that there's only 1 digit, and we can say 5 times 10 to the third. Finally, we can add zeros as placeholders if we want to take a number out to more digits than is shown. So for example, if we wanted 5 digits, we can simply add a 0 after the 9. It's not changing the number, but it's changing how many digits that we have. Let's look more at how we made these scientific notation numbers for the second and 1 digit. So scientific notation, you have your value that only has 1 number in front of a decimal, and then it's times 10 raised to a power. If that integer, or if that exponent is a positive number, that means that the original number was very large, in the hundreds, thousands, millions. If it's a negative exponent, that means it was very small. So it's a very small decimal number with lots of zeros before you get to your first actual number. So if we look at an example, we have 0.00012. So we need to first put the decimal between the first non-zero digits, which would be the 1 and the 2. And then count how many times you have to move that decimal to get it to be there. So that would be 1, 2, 3, 4. So my exponent is going to be a 4. Because this number is less than 1, it's going to be a negative exponent. So we have times 10 to the negative 4. If the original or standard notation number was larger than 1, have this number for example, the exponent would be a positive number. So the only number we have that is not 0 is a 6. So we're going to want to move the decimal so that's right behind the 6. In other words, we're going to get rid of all these zeros. Then we have to count how many places we move the decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 6 times 10 to the 12th. Again, the positive integer, larger than 1. For the standard notation, a negative exponent, smaller than 1. When you're doing scientific notation in the calculator, you want to use your exponent button. If you're using the calculator that I provided the link for on the syllabus, you would be using this EXP button right here. If you have a regular scientific calculator that you brought from Target or Walmart, it usually has an EXP button down towards the bottom near the equal sign. If you're using a graphing calculator, it's actually a double capital E button, EE. And it is located above the 7. You just have to hit second and then the double E button. So if we're going over this first problem, we would type into our calculators 4.2. Then we're going to use that special button to represent the times 10. So 4.2, and then that special button, either the double E or the EXP, And then you just have to type in the exponent, which would be a 4, plus 7.9, that special button, 5, and then equals. Now here we want the answer to be written with 2 digits. So this is how our calculator gives us the answer. We only want 2 digits though, so we're going to keep the 8 and the 3. And so we could replace the 2 with a 0, or we could write this in scientific notation and say that it is 8.3 times 10 to the 5th. Looking at one more example, we would type in our calculator 5.23. We would hit that special button. Remember, it's the double E or EXP, and then -2. You don't need to hit the caret button. You don't need to say raised to. It's just that special button. Then times 7.1 EXP or EE -8. Our calculator should give you an answer like this. Notice that it already has the scientific notation there. Some of your calculators, it might have just the letter E. That means times 10 raised to. So we don't want to write the letter E. We want to write times 10 and then put our exponent there. Now we want 2 digits. So again, we're going to keep the 3 and the 7. The 1 does not round the 7 up. So that's just 3.7 times 10 to the -9. And then one last thing for this math review is direct proportions and inverse proportions. A direct proportion, you should see the graph creating a straight line with a positive slope. That means as you increase one value, the other value is also increasing. An inverse proportion gives you this downward sloping curve. That means as you increase one variable, the other variable is decreasing. So direct, both do the same thing. Inverse, they do opposite things.